So this is the modern periodic table which was designed by H.J. Moseley, and today this periodic table we are using now. Now let us find out how to find out the particular element for a group and period. Hello everyone, welcome back to my channel Physics for AP. So in our previous part we were explaining about the modern periodic table. So we have seen about the features, that is the groups and the periods, and also we have seen about the modern periodic table, the part which is the S block, P block, D block and the F block, and we have seen about the valency electrons and the valency. Now for example, in the competitive examinations they may ask some of the elements, like they give an element which, like for example we have aluminium. So they give an aluminum and they will tell you to find out in which group and which period does it exist in the periodic table. So for that, most of them what they will do is they will memorize the whole periodic table. So it is also a good part, but a small technique to find out that the elements which exist for which group and which period. We have an technique over here which belongs below to 20 elements. The elements which are below to 20 elements, that we can find out that which periodic table in the group and period does it exist. Now for example, we have taken aluminium. So aluminium atomic number is 13. So what we need to do is, first we need to write the electronic configuration of the aluminium. So 1s2, 2s2, 2p6, 3s2, 3p1. So this is the electronic configuration for 13. As for 13 electrons, we have distributed the 30 electrons for the respective energy levels. Now here we consider this 1s, this is the first shell which is called the K shell, and the second 2s2 2p6 which is the second shell, that is the L, and the 3s2 3p1, this is third shell which is the M shell. Now what you have to do is you need to take the outermost shell, the outermost orbit over here. So this is the outermost shell, so that is the M shell, which we have the 3s2 and a 3p1 over here. Now in this case, what you have to do is first write down the group and write down the period, so that it will be easy for you. Now here, as we have three shells, that is 1 2 3, as we have three shells over here, so the period belongs to the number 3, that is aluminum belongs to the third period, as the number of shells which are present here, which is the third period. Now coming to the group, so the group as the number of electrons which are present in the outermost orbit. So the outermost orbit we have the M, which has the number of electrons 2 plus 1. So 2 plus 1 is nothing but 3. So 3 electrons we have, which the group belongs to 3A group. So again I am telling you, this method is only below the 20 elements, that is starting from hydrogen and up to calcium. So this method is available, and also it is easy for up to from hydrogen to calcium. Now for example, if we take for calcium, so the atomic number is 20. So when we write the electronic configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, and next comes for 4s2. So 10 20, so 20 electrons has been filled for the respective energy levels. Now this is the first shell, K shell, this is the second, L shell, and this is the third, M shell, and this is the last N shell, that is the fourth shell. Now coming to the group and period, so which group and which period does it exist, that we need to see. So period, as if you see here, we have 1 2 3 4 shells we have, that means the period is 4, that means it belongs to the calcium belongs to the fourth period. Now coming to the number of electrons in this outermost shell, we have 2 electrons. So as we have only 2 electrons, so the period will become as 2A. Now let's take another example for oxygen. Atomic number 8. So when we write the electronic configuration, that is 1s2, 2s2 and 2p4. So this is the electronic configuration for oxygen. So this is the first shell K and this is the second shell L. So outermost shell is the L shell. So when you write the group and period, so period, as we have two shells, so the period is 2, that is the second period. Group, now find out the number of electrons which are present in the outermost orbit. So what is the number of electrons? Yes, 4 plus 2, 6. So as we have 6 electrons, so it belongs to 6th A group. 6A group. So this is how you need to find out for to which group and which period does it belongs to. That it is a simple technique and which is available only for the hydrogen to calcium. So you can find out this for any type of elements, like from hydrogen to calcium, by doing the electronic configuration. So for the remaining elements, that we'll be seeing in the next episode, next part. And next, when coming to the anions and cations, this is a small introduction part which is for the next upcoming thing. As for anion and cations, so when we have ions, so ions are nothing but the charges, the free charges, that is when an electron is being removed or when an electron is being added, so we get an ions over here. So ions are of two types, one is of cation and another one is of anion. Cation and anion. So cation represents for the positive charge and the anion represents for the negative charge. So how can we get a cation, how can we get an anion? So let us see. For example, I am taking an element like sodium. Sodium atomic number is 11. So when we write the electronic configuration, we write 1s2, 2s2, 2p6, 3s1. So this is the electronic configuration for the sodium. So this is the first orbit and this is the second orbit and this is the third orbit. So as you can see, 3 orbits, that is 3 shells are there. So the sodium belongs to third period, and in this third period, last outermost orbit, we have only 1 electron, so it belongs to 1A group. So 1A group, third period. Now coming to the sodium, now when we draw its atomic structure, the first orbit, that is the K shell, which has 2 electrons, and coming to the second orbit, which has 8 electrons, 6 plus 2, 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8, and another 1 electron which is in the third shell, another which is in the electron which is the third shell. So that is represented the outermost orbit. As we have seen in the principal quantum number, that only 8 electrons will be fit in the second shell. So that is the 2n square formula. So once revise the structure of atom. Now here we have 1 electron in the outermost orbit. So here we will be having an octet rule. So octet rule is nothing but outermost orbit should exist of 8 electrons by removing an electron or adding an electron. So octet rule is nothing but we should get 8 electrons by removing or adding it. So electrons should be added or it should be removed to get 8 electrons in its outermost orbit, so that it can be ready to combine with the another element, like what we call the bonding, which we will get in the chapter called the chemical bonding. So that is getting combined with another one to form a compound. So as if we see here, sodium, the first orbit has 2 electrons, the second orbit has 8 electrons, and the last orbit has 1 electrons. Now in this case, to get 8 electrons in the outermost orbit, we have to add 7 electrons to it. 7 electrons to it. That means more amount of electrons should be added for the outermost orbit to get 8 electrons. But instead of that, if we remove this 1 electron, then automatically we will get the 8 electron in its outermost orbit. So which is easier for us, to add 7 electrons or to remove 1 electron? Yes, so to remove 1 electron is easier than adding 7 electrons. So we will remove 1 electron. So this 1 electron is been removed out. So by removing out, what will be get here? So sodium, it will become as Na+1. That means it will become a positive charge. So when we remove an electron, we get a cation. So cation is nothing but the removing of electron or losing of electron, what we call the losing of electron. So why do we get a positive here when we remove an electron? Simple is that as sodium we have 11 electrons. That means it exists of 11 electrons and 11 protons in it. Now when we remove an electron, that is -1, so we get how many electrons here? 10 electrons. As if we see here in the picture, if we remove one electron, 2 plus 8, that means 10 electrons will be present. Now 10 electrons. Now what about the protons? So protons, we are not changing it, we are not removing or we are not adding the protons. The protons which are present in the nucleus are same itself. So here we have 11 protons. Now as if we see 11 protons, 10 electrons. Who is greater here? Is it a negative charge or positive charge? Yes, positive charge is greater. How many times it is greater? One time it is greater. So we get sodium as +1. The same thing also if you go for aluminum. Aluminum, we have atomic number as 13. Now if you see the atomic structure of aluminum, first electron, it consists of 2 electrons. The second atom, it consists of 1, 2, 3, 4, 5, 6, 7, 8 electrons. And the last third orbit, it exists of 1, 2 and 3 electrons. So the outermost orbit has 3 electrons here. Now to get octet configuration, what we have to do is we have to add 5 electrons to it. So instead of adding 5 electrons, we will remove the 3 electrons, so it will be easier. So when we remove the 3 electrons, we get aluminum as we are removing it, plus how many electrons we are removing? 1, 2, 3. As 3 electrons are removing, so we get Al+3. The same thing as if we take aluminum, as we have 13 electrons and 13 protons. So we are removing 3 electrons, so it becomes as 10 electrons, and protons we are not changing, so we get 13 protons. Now who is greater here? Protons are greater. So how many times they are greater? 3 times they are greater, so we get Al+3. Now when we go for the anion is the negative charge, is that when we add an electron. So when we add an electron, so we get an anion. So like example, if we take for chlorine atomic number is 17. Now if you see 1s2, 2s2, 2p6, 3s2, 3p5 is the electronic configuration for the chlorine. Now this is the first orbit, K shell, and this is the second orbit, L shell, and this is the third orbit, M shell. Clear? Now this chlorine, as it has 3 shells, it belongs to third period, and the outermost orbit, this is the outermost orbit, it has 2 plus 5, 7 electrons. That means the chlorine belongs to 7th A group. Is it clear? Now coming to the chlorine atomic structure. So first orbit has 2 electrons, and the second orbit it has 1, 2, 3, 4, 5, 6, 7, 8, and the third shell, it has 7 electrons in it. So 1, 2, 3, 4, 5, 6 and 7. Now as the outermost orbit has 7 electrons, now to get 8 octet rule, that is 8 electrons, we need to add or we need to remove. So here we have 7 and here we have 8. So removing 7 electron or adding 1 electron, which is easier for us? We cannot remove the 7 electrons. So which is easier for us? Just adding 1 electron. So when we add 1 electron, it becomes 8. So it gets octet rule. Then we get an anion. So when we add 1 electron, it becomes Cl minus 1. Why? Because we are adding 1 electron. So as if we see chlorine atomic number as 17, we have 17 electrons and 17 protons. So when we add 1 electron, so 17 plus 1, we get 18 electrons, and the proteins, there are no change in its it. So 17 protons. Now who is greater here, electron or proton? Yes, electrons are greater, so we get a negative charge, minus. And how many times it is greater than the proton? It is greater than 1 time, so we get as -1. Now same as for oxygen, if we take for oxygen, so if we draw the atomic structure of oxygen, the first shell it takes 2 and the third shell it takes as to 1, 2, 3, 4, 5, 6, 6 plus 2, 8. Now in its outermost orbit 1, 2, 3, 4, 5, 6, 6 electrons are there. Now to get octet we need 2 more electrons. So 2 more electrons will be added into it. So when 2 electrons are added, so oxygen becomes minus 2. That is, as oxygen has 8 electrons and 8 protons, by adding 2 electrons it becomes 10. As there is no change in protons, 8. Now who is greater? Yes, electrons are greater. So electron charge is negative. So it is negative. So how many times it is greater than proton? So it is greater than 2 times. So we get as O minus 2. So this is how we get the formation of an anion and a cation. So cation is the positive charge and anion is the negative charge. Clear? So anion is nothing but it is a positive or negative charge. So why do we need a cation and anion? Because due to the formation of bond. Like for example, if we take here Na plus 1 and if we take here Cl minus 1, so when you combine Na plus and Cl minus 1, as a positive and negative both get attract to each other, so we get NaCl. As another one we can say as for magnesium or aluminum, let's take as aluminum as we have done here aluminium. So aluminium is Al plus 3. And here oxygen we have O minus 2. So oxygen we have as O minus 2. So when we combine these two, what we'll get here? Simple, by crisscross method. So this crisscross method is nothing but, so if we have a positive ion and if we have a negative ion, and those two should be get crisscross, that is 2 will come down over here and 3 will come down over here. That is Al2O3. That is the 3 belongs to the aluminum and 2 belongs to oxygen, they get crisscross. Now for example, if both are same, that is these values are both are same, like example if we take for magnesium, so magnesium we have plus 2, and if we take for oxygen O minus 2, now plus 2 minus 2 that both gets attracted, and by doing crisscross method we get Mg2 and O2. Now as their two values are same, so both get cancelled by dividing 2, that is 2 ones are, so we get the overall value as MgO as a compound. So this all you will be learning in the chemical bonding chapter, which is the upcoming chapter that we will be learning later. So today what we have discussed is, we have discussed about how does a group and period, how to find the element, a specified element in a group in a period by using this. So this is nothing but as if you see here the general electronic configuration here, like for example if you take as Ns2np3, so 2 plus 3 outermost electronic shell, 2 plus 3 5, so that belongs to 5a, or otherwise 6 plus 2 8, that is nothing but 8a. So like this you can be finding out the group, and the period can be find out the number of shells, how many shells you have, 1 2 3 4 is the greater, that is it belongs to the fourth period. So like this you can be finding out the group and period. And next we have seen about what is meant by an anion and cation. So how do we get an cation and how do we get an anion? So cation is nothing but the removing of electrons, and anion is nothing but addition of electrons or adding of electrons. So adding of electrons. So if you remember all this, the formation of cation and anion, the further it will be very easy for you to understand the concept of physics. So these are the basics that you need to learn before going to the further chapters. So clear? So right now, thank you for your time. If any doubts regarding it, please give a comment as your doubt, and subscribe the channel, click the like button, and all the best for your preparations.